Hey, welcome back to trigonometry. We're just about finishing our first chapter, which you'll notice I'm not calling by name because this course hopefully will be used by many instructors and should be bookend specific. Pretty much the outlay of how trig is taught is relatively uniform across the universe and time. Not really. Some of the things we were talking about, once again, this will probably be one of the last times I draw this up, the specific. Here's your generic triangle of angle alpha. Here's x. Here's r. This is x squared plus y squared square root. We define the sine of alpha is equal to y over r. The cosine of alpha is equal to x over r, and that's not a handsome x. And the tangent of alpha is equal to y over x, which is also equal to sine alpha over cosine alpha. It depends what form you're going to use as to which of these is easier. And it just depends on the problem. Now we also defined some other functions that are these functions essentially upside down. 1 over sine alpha, which we're going to call cosecant alpha. This is this upside down. This is r over y. 1 over cosine alpha. This is the same as, we're calling this secant alpha, and this is r over x, and 1 over tangent alpha, which we're going to call cotangent alpha. This is x over y. It's just upside down, and you can also write this as cosine alpha over sine alpha. And these 6 trigonometric forms show up all the time. There are several relationships we need to know about them. I haven't really shown you many of the graphs. I've shown you the 3 primary graphs, but I haven't really shown you these graphs very much. Actually, I haven't at all, and I'm going to rectify that right now. First, let's take a look at cosine. And I'm just going to graph it from 0 to 2 pi because cosine is periodic with 2 pi. And this is, in general, an easy way to graph trigonometric functions because they oftentimes are very easy numerical values at pi, pi over 2, something like that. It's pretty easy to remember these. 3 pi over 2 and 2 pi. So remember that cosine of 0 is 1. I better put this up here, 1, and this will make this about -1. So it starts here. Cosine of pi over 2 is 0. Cosine of pi is -1. Incidentally, all of these you should really know by heart. Cosine of 3 pi over 2 is 0, and cosine of 2 pi, of course, is 1. Remember, when we say that it has period 2 pi, basically it starts over again. The entire shape starts over again every 2 pi. Okay. So this is cosine x. A question you might want to be asking now is, what does secant x look like? And this is 1 over cosine x. And now I'm going to split this up. I'm going to put this 2 pi in either direction so you can see what's going on here. Pi over 2, pi, 3 pi over 2, and 2 pi. Minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. How are you going to graph this? How can you even think about this? Well, the first thing is we have to make sure we're not dividing by 0. Anywhere where cosine x is 0, we're in trouble. It's got to have vertical asymptotes there. And we have some color, so we might as well use it. And I think our vertical asymptotes should be red. Where is it 0? It's 0 at pi over 2. It's 0 at 3 pi over 2. And also, because cosine is an even function, it must be 0 at negative pi over 2 and negative 3 pi over 2. Okay, so these are some guidelines we're building in for this. So we know, what do we know about cosine? We know that cosine varies between -1 and 1, right? So the biggest it can ever be is 1. So what's the smallest this can ever be? Well, if the biggest this can be is 1, 1 divided by 1 is 1. So 1 is the smallest that this can be. Or, well, okay, so that's not entirely correct because it could be negative 1, right? Negative 1 is smaller. Let's think about what happens when cosine x is 1. And I'll put this line right here. Here's 1. Here is not negative 1 because it'd be right about here. So when cosine x is 1, secant x is also 1, right? So here's a place for this. When cosine x approaches 0 and it's still positive, what's going to happen? Well, as you divide 1 by a small positive number, this shoots up. So basically, this is going to do this. Similarly, by symmetry, this is going to do this, because cosine is an even function, which means that it's symmetric with respect to the y-axis. What about when cosine is pi, or cosine at pi? Cosine pi is negative 1, that means secant will be negative 1, so this will be here. Now similarly, cosine is negative from pi over 2 to 3 pi over 2, and what's going to happen is, as you approach 3 pi over 2, it's going to 0, but it's going to 0, it's going to be a small negative number, so I suppose it'd be better to do this. It's going to shoot down to negative infinity. This one went up to positive infinity, so it's going to do this. Similarly, by symmetry, we can do the same thing here. And my graph is looking a little off. Okay, and basically this pattern is going to be repeated. Over on this side, it'll be like this. Some stuff's going to... Actually, that's enough. Okay, so this is cosine. So secant, which is cosine upside down, just looks like this. You should know how to derive these graphs, but the truth is I don't remember using it that much. Secant gets used quite a bit. The deal is, when I was in school, it was before graphing calculators, and there were computers, but not very many people had access to them. Knowing basic graphs was very important. You have so much technology available that all you have to do is punch this in and you'll get this up. I just want you to see it. For the moment, I can't think of how knowing this picture will be particularly important, except in a general way. It may be a question comes up that knowing how this looks will help. As a matter of fact, that's almost certainly true. Especially really knowing that where is this? What are the values from? It's from infinity to 1 and negative infinity to negative 1, but there's nothing in between, and this may be important. Now, as far as sine goes, sine x, we know that sine x is cosine x shifted over by 90 degrees. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1, which is going to be about here. And sine of 2 pi is 0. Okay, so this is the sine of x. And these two graphs in particular, sine and cosine, you definitely want to know just as well as you can spell your name, because they're going to show up all the time. Knowing these basic graphs is really important. So we're going to take a little break, and I'll be back in a minute to draw this picture up.